Hi, so now we have to test this ATM, and this ATM allows you to withdraw money from 20 euros to 200 euros. Intervals are included, so you can withdraw 20, you can withdraw 200 euros. But it only allows you to do in increments of 20, so you can get 20 euros or 40 euros or 60 euros, so on and so forth. In real life, of course, the ATM would give you the money. In here, for the purpose of this example, let's suppose the program just returns true or false if the amount of money required by the user is valid or not. Let's do the analysis of the variable. So we have the amount, which I'm considering here as an integer, but I can enumerate them all, right? 20, 40, 60, 80, up to 200. And as an output variable, true or false, I called it valid. So given that we can enumerate them all, this means that in my equivalence partitioning and boundary analysis, all of them will have to appear, right? Because all of them are, and I'm considering here different classes. So that's what you see in my table over here. Then we can do boundary analysis. And this 20 and this 40 and this 60, I'm considering like an equality boundary. So I have always two off points. Yeah, so for example, in the case of 20, I'm putting 19 and 21. And I repeat this for all the boundaries. So this is what I have here. And if I see the count, actually there are 30. Okay. Then these are the valid equivalent classes and their respective boundaries. And I can also think of invalid classes. For example, -1. -1 might be a bad example because maybe it's just impossible to force a -1. But I think if I were really testing a real ATM, which is an embedded system, I would try, for example, I would type 20 and I wait a few seconds to see how the program reacts, or I would type 20, I would delete 20, I would type 20 again, delete again, 20 again, these kind of things to see if we could crash the software. Again, I'm seeing this as a black box, so we still don't have access to the source code, so this could be reasonable invalid classes that you could exercise in this type of system. Okay, so this -1 is quite representative there to indicate that you have to consider invalid classes. And those are, of course, dependent on the domain. So then, given that this equivalence partitioning gives us the classes we want to test, and of course we want to test them all. As an outsider, we don't know the source code. Maybe this would change the way we do it if we saw the implementation, right? But we don't right now. So then I think the reasonable thing to do would be to test all the partitions, test all the boundaries because bugs could be there, and test some invalid classes, right? That's what I would do if I were doing black box testing. We don't know the software. However, well, if we were to know the implementation, I could suppose that a developer would get the amount of the income. It would do something like, if income, if the rest of the division per 20 is 0, this is kind of a valid number. If the income is in between, I don't know, greater or equals to 20 and smaller than or equals to 200, maybe that's the implementation, right? So if I see this implementation, then I definitely have less classes to test. So that is a trade-off you have to do. That's the point I'm trying to make here, right? Sometimes if you have access to the implementation, maybe you combine both information requirement and implementation, and then we decide which tests to do. So that is what I wanted to discuss. And in here, what I decided to do at the end, I decided to test all the specific points just to be rigorous enough, but not all the boundaries. Yeah, because again, maybe the way boundaries are handled in the implementation I showed there, they are very similar. So I just tested a few of those off points. I put 3 here. 3 was a random decision, and then the invalid classes. Okay. So again, just to focus on the main point of this video, which is so far we saw everything as a black box. And maybe seeing everything as a black box might make things more complicated, or it might make you to spend more money, more time in testing. But taking the source code into account might also change the way you do things. Okay, we're going to discuss how to take source code into account in future lectures, but this is just a discussion I wanted to trigger in your minds.